Hi, this short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. In this clip, we're looking at the particles and waves section of the course, and we're looking at the forces on charged particles. So here's an example of the question. An electron out for a stroll in the electromagnetic countryside finds itself entering a magnetic field. It also discovers it cannot help but change its direction. Which way does it start to move? Toward the top of the page, out of the page, into the page, carrying on across the page, or it turns around and goes back the way it came. So, standard procedure, we need to read the question closely, pick out the things we're being asked about. I mean, here we can ignore the story and we know we're looking for which way does this electron move when it crosses the magnetic field. Look at the question, see if there's anything obvious we can ignore. Well, I'm kind of thinking E looks a bit like we could obviously ignore it. Recall what part of the course is being referred to, read the question again in your head, and if it's overcomplicating, stop and start again. So what do we have to do? Well, this is one of the questions I do find the most difficult because I find visualizing in 3D quite difficult. So what's happening and what do we need to do? Well, we need to remember that when we are dealing with charged particles moving in magnetic fields, that the directions they end up going in depend on two rules. The left-hand rule for positively charged particles and the right-hand rule for negatively charged particles. Now, on the whole, the rules are the same. They're just using different hands. So here we are talking about a negatively charged particle, an electron. So what do we have to do? Well, it's an electron, it's negatively charged, so we need the right hand rule, and here is our right hand. Now, for both the right and left hand rule, we need to align our fingers and thumbs as shown. So the thumb needs to be pointed upwards to start with, then the first finger pointing out as if you're pointing a gun shape, and then your second finger at right angles to your first finger. Having got that right, we need to remember that the first finger will point in the direction of the magnetic field. The second finger will point to where the particle's headed, and if we've got those two correct, then the thumb will show us where the particle's going to end up going. So let's try that in reality. Here's our electron, negatively charged particle about to head into this magnetic field. So the first finger is the direction of the magnetic field, so it needs to point up. So we'll point that up. The second finger then needs to point in the direction that the electron is going. So that feels naturally a bit uncomfortable because we have to twist our hand all the way round so that our finger in the our first finger points upwards and our second finger points to the right. So the particle is moving left to right, so our second finger should point to the right. Now, where does that end up leaving your thumb? Well, in the way I've got my hand right now, the thumb is pointing towards my laptop screen, so that's into the page. So I think that particle will move in and then down towards into the page. And that's the correct answer, and that's what we can go ahead and identify as the correct answer, C, into the page. So key things to note here. In this scenario, we need to remember the right and left hand rule, but remembering they're more or less the same rule, it's just different hands. The fingers and thumbs do the same things. You need to be ready to twist your hands around. And if you see others in the exam room using their hands, maybe that's something to keep an eye out for, see which hand they're using. Of course, they could have it wrong. But positively left is all you need to remember. If you remember that positive is left, then you can only be left with negative is on the right. We have a few more for you to try here. Answers as always on our Hi page, hi.page/physics, FYSX. So pause here, give that a go. And thanks for watching. See you on the next question.